Good day, viewers. Today we are going to be looking at a limit and has done a lot in calculus and trigonometry. And the function we are going to be talking about, or the limit, is the limit of theta to 0 of sine theta over theta. According to normal knowledge of mathematics, this is supposed to lead to infinity. But no, using some special and technical skills in mathematics, we can tell that the limit of theta to 0 sine theta over theta is actually equal to 1. And that's what we are going to look at in today's topic. So we want to establish the fact that limit theta to 0 sine theta over theta equal to 1. So we need a reference circle for this. Assuming we have a circle and the center of the circle O to this point T, this point P, and if this line should extend out, this line meets here at 90 degrees, and let's name this point X. This angle should be theta, and we'll find out that since OP is the radius, it's going to be R, and OT is also a radius, it's going to be R. So from here we can find out that OT equal to OP equal to R. Now, from what we've seen here, we have triangle OTP. We also have sector OTP. And if we look at this technically, OXP is another triangle, triangle OXP. So this is our diagram that we're going to use to prove the limit, that limit x to 0 sine theta over theta will be equal to 1. Let A1 be equal to the area of triangle OTP. Let A2 equal to area of sector OTP. And let A3 be the area of triangle OXP. So from what we are seeing here, A1 is this area OTP, the area between this triangle. This is A1. And from what we see here, A1 would be less than A2. Reason being that A2 includes this area. So our A1 would be less, since A1 is only this triangle, but A2 is the triangle plus this area. And obviously our A3, which is the area of this triangle involved here, meaning it's going to be greater than A1 and A2. So we can establish the fact that A1 less than A2 less than A3. So our A1 is the area of this triangle. So let's bring out the triangle and see what we have. If we should bring out that triangle, it looks something like this: theta, R, and our R. And let's take here to be our base. If we should turn or rotate this angle and make it bigger, we would have something like this: R, R, base, and this H is our height, the angle here being theta. Now if this angle is theta, we'll find that this is a perpendicular bisector. So this angle, new angle, would be theta over 2. So how do we find the area of a triangle like this? Well, you know from the initial formula of an area of a triangle, that area is equal to 1 over 2 base times height. And this portion here to here is base divided by 2. So we see that sine theta over 2 from this is equal to opposite, which is base over 2 divided by hypotenuse r. So our r sine theta over 2 is equal to base over 2. So therefore, the base of our triangle is equal to 2r sine theta over 2. Now this is a way forward. We have to look for our height. From this same triangle, we can see that cos theta over 2 is equal to height over r. So therefore, height would be equal to r cos theta over 2. So with our 2, we found our height and our base. All we need to do is substitute it into this formula. Therefore, our area would be equal to 1 over 2 base 2r sine theta over 2, 2r sine theta over 2 multiplied by our height r cos theta, r cos theta over 2. 2 goes, 2 goes. A would be equal to r sine theta over 2 cos theta over 2. A. Now in trigonometry, we know that sine 2 theta is equal to 2 sine theta cos theta. This also implies that sine theta is equal to 2 sine theta over 2 cos theta over 2, meaning sine theta over 2 cos theta over 2 equal to 1 over 2 sine theta. So r times r is r squared. So therefore, we see sine theta over 2 cos theta over 2, sine theta over 2 cos theta over 2. Substituting it, we find our a will be equal to 1 over 2 r squared sine theta. So our a1 is 1 over 2 r squared sine theta. Now our objective, we found a1. It's time to move on to look for a2. So a2 is the sector, the area of the sector. A2 is the area of sector. That is, from our reference circle, we can find out that A2 is the area of the sector OTP. Now that sector, the area of the sector is theta over 360 multiplied by pi r squared. But this is when theta is in degrees. In this part of mathematics, we are going to deal with theta in radian. So therefore, the area when theta is in radian is 1 over 2 r squared theta. So our A2 is equal to 1 over 2 r squared theta. Now let's go to our A3. From this diagram, our A3 is the large angle outside. So our A3 already is a right angle triangle with here as x, this point has t, this is theta, this is r, and this is p. The area of a triangle is 1 over 2 base times height. Our base is r. Height is xp. And we know that our xp is equal to r tan theta. How? Tan theta is equal to opposite xp over adjacent. That is how we get xp opposite over r adjacent. By cross multiplying, it leads to this. So therefore, our a3 is equal to 1 over 2 r multiplied by r tan theta, because our base is already r. Therefore, a3 is equal to 1 over 2 r square tan theta. So we've established the fact that a1 is equal to 1 over 2 r square sine theta. A2 is equal to 1 over 2 r square theta. And finally, a3 is equal to 1 over 2 r square tan theta. Using our initial equation, that a1 less than a2 less than a3, we can tell that 1 over 2 r square sine theta less than 1 over 2 r square theta, and it's also less than 1 over 2 r square tan theta. Now we're going to divide throughout by 1 over 2 r square sine theta. Dividing here 2 by 1 over 2 r square sine theta, and dividing here by 1 over 2 r square sine theta. There we get our answer as 1 less than theta over sine theta less than 1. Then tan theta is equal to sine theta over cos theta. So this is 1 over cos theta. Now how we got this? If this goes, this goes, this goes, this goes. Tan theta is equal to sine theta over cos theta. So sine theta over cos theta divided by sine theta, this would be equal to sine theta over cos theta multiplied by 1 over sine theta, and there we would have 1 over cos theta. So if we have our equation now, so we now have it that 1 less than theta over sine theta less than 1 over cos theta. From this equation, from this diagram, we can tell that if theta gets smaller and smaller, these areas get smaller and smaller and even more closer to themselves. And at a very small theta, the areas might be approximately equal to each other. So we can now show that at a small theta in radian, 1 will be less than or equal to theta over sine theta less than or equal to 1 over cos theta. If we invert all of this, we see that 1 greater than or equal to sine theta over theta greater than or equal to cos theta over 1. That is, by inverting all this, the sign changes too. So from what we can see here, we see that as theta goes to 0, cos theta tends to 1. That is, if we should limit all of this theta to 0, cos theta will go to 1. Thereby 1 greater than or equal to sine theta over theta greater than or equal to 1. So from what we can see, we see that sine theta over theta is sandwiched between 1 and 1, because this is interpreted 1 greater than or equal to sine theta greater than or equal to 1. So from what we can see, sine theta, the limit of sine theta over theta to 0 would be equal to 1, because when we limited theta to 0, we find that theta over theta, sine theta over theta, is sandwiched between two values, which is 1. I hope we all understood how to derive or how to prove that limit of sine theta to theta, limit theta to 0, is equal to 1. We started from here, the triangle, the circle, and then the diagram, to get the area of the triangle, then the area of the sector, and the area of the larger triangle outside. From all our calculations and solving, we came to the point that we found out that the first area, which is the area of the internal triangle, is this, the area of the sector is this, and the area of the outside triangle, the external larger triangle, is this. From here, we deduced and we derived the fact, and we established the fact that limit of theta to 0 of sine theta over theta is equal to 1. Thank you very much for watching. Please ensure to subscribe to my channel, drop a like, and leave a comment. Thank you very much.